All right. Okay. That takes care of that. All right. I don't have a question of the day for you today, ladies and gentlemen, but I do have an announcement for you, a reminder for you. Next week, Tuesday, you'll be taking another quiz. It'll cover those changes in properties and signs of a chemical change and things that we are working on right now. Okay? So, quiz next week, Tuesday for you. I will keep reminding you. Our learning target today is we're going to be able to understand the signs of a chemical change. Yesterday we talked about what a chemical change was. We talked about what a physical change was. Today we're going to talk about the signs of a chemical change. Okay? So we're going to finish up that properties identification lab we started yesterday. We're going to take a look at signs of a chemical change. It's one slide in our notebook. And then we're going to do a lab activity where you are going to look at some changes and you are going to determine if they are chemical or physical. So that applies what we are going to learn right away. Just a reminder, and I keep telling you this, and I keep telling you this, and I keep telling you this, and I'll do it all trimester long. We are basically next week Friday, 1 week from, or next week Thursday, 1 week from today, that is the end of the third grading period, which means we will be halfway done with this trimester. So again, go online, check Infinite Campus. If you are missing things, you need to let me know. If you need something, I will put it in there for you. What I mean by that is, if you're missing a quiz, you just got to come to me and say, hey, I'm ready to take my quiz. And to be honest with you, ladies and gentlemen, if you have a 0 on it, that's hurting you more than even if you do poorly on the quiz. So at some point, you just have to come in and take the quiz. I think most of you guys have your test done. That's not a problem for most of you. But if you're missing a lab, if you were gone on the day of a lab, I have alternate assignments for every lab we do. But you need to open the lab first so I can put in the alternate assignment, and then you just need to let me know, hey, Mr. Brand, I opened this lab. Can you put in the alternate assignment for me? And I will do that. The alternate assignment can be done without you having to be here on the day of the lab. So, for example, this aluminum copper chloride lab that we're going to do today, I have an alternate one out there for the students who aren't here today. So just keep that in mind. Okay? All right. So yesterday, ladies and gentlemen, we gave you an activity to do, and I probably need to do a little bit better at that than I did yesterday. What I mean by that is we should have taken a little bit more time together and gotten some information. So what I asked you to do was identify 4 clear liquids based on their property. The liquids were all clear. The liquids were all colorless. It is very difficult for you to know what is in these 3 containers because they are all basically the same color. We can't tell just by looking at them. Okay? Now, some liquids have an odor to them. We learned that yesterday. What 2 liquids in our lab activity yesterday had an odor in them? Alcohol and vinegar. And most people can recognize alcohol by its smell. Most people can recognize vinegar by its smell. The problem sometimes comes is when you're trying to smell one and then the other and then another and then another. Because what happens is sometimes when you smell one thing, then you go and smell another, the scents may kind of mix in your brain, if you understand what I'm saying. It becomes different to distinguish one from another. Which is why if you've ever gone shopping for like colognes or perfume, in that area they have all those scents, but then they also have something like coffee beans around. And the reason they have something like coffee beans there is you're supposed to smell it, and it kind of clears your mind. so that when you smell the next thing, you know exactly what you're smelling. But we should have hopefully been able to identify alcohol and vinegar by their scents, which means then we could identify water and sodium hydroxide by the fact that they do not have an odor. Okay? So now we separate it. Now we got two jars that we're trying to figure out which one is alcohol, which one is vinegar. Two jars that we're trying to figure out which one is water and which one is sodium hydroxide. Fair enough? Now, I then gave you a couple of other tests that you could use. The other tests that I gave you that you could use, ladies and gentlemen, were, is it flammable? Okay? So if you looked up, and by the way, Google is a wonderful thing. You could literally type, is water flammable in Google, and it will give you an answer for if it is flammable or not. And if you did that, you would find out that no, water is not flammable. You would find out that vinegar is not flammable. You would find out that sodium hydroxide is not flammable. And hopefully you already know that alcohol is. Point being, ladies and gentlemen, you don't have to ask Google if you already know this. But you need to make sure you know this. Now, sodium hydroxide, you're probably not familiar with that. That one you probably had to Google. Okay? Do any of these have colors? Well, we could have told you that just by looking at them. They were all clear. They were all colorless. Okay? Do any of these have an odor? As Karina told us, water, no. Alcohol, yes. Vinegar, yes. And then you might have had to look up, does sodium hydroxide have an odor? Because again, something that you're unfamiliar with, you're going to have to look things up. You're going to have to do a little research. But because these are properties, these are things that are known about these substances, they can be looked up. And that is part of what we were trying to teach you as well, is that you can look up properties. Okay? Now, we could have used a property like boiling point. We could have looked up what temperature each of these things boils at. And if they boil at different temperatures, we could have put them on a hot plate with a thermometer in there and saw what temperature they boil at. That could have helped tell us what is in there. We just didn't have time to do that. So we kept it a little more simple. Now, the one that you definitely had to look up, ladies and gentlemen, was this one. Does water react with phenolphthalein? Because again, something you are totally probably unfamiliar with. Phenolphthalein is what is called a chemical indicator, ladies and gentlemen. Chemical indicators will react with certain substances. There are chemical indicators that will tell you if you have iron in your water. There are chemical indicators that will tell you how much chlorine or fluorine or impurities are in the water in a fish tank or possibly in a pool. And people can look at these and tell different things by looking for changes in color. Phenolphthalein is one of those indicators. Now, phenolphthalein is an indicator that reacts with something called a base. Any base, when it comes in contact with phenolphthalein, it will change it to being purple colored. Of the 4 liquids that we had yesterday, ladies and gentlemen, only one of them was a base, and that was sodium hydroxide. Which means that if you put sodium hydroxide and phenolphthalein together, you get a nice bright purple color. Nice bright purple color.
Could that be used to like color, I don't know, a sheet of paper?
It could stain a piece of paper, yes, but it's not like if you drop that phenolphthalein on a sheet of paper, it's going to turn purple. It will not. It will not. But if you take the liquid that was already changed and put it on a piece of paper, yes, it would stain it. Yeah, definitely. Okay? So this indicator only reacts with bases and it only turns purple. And normally that's what indicators do. They turn one color or another. Okay? So when it's with a base, it turns purple. If it were with an acid, it wouldn't change any color at all. So with these 3 other liquids, there should have been no color change. Okay? Now, I asked you to also look up toxicity. Is water toxic? No, we drink it all the time. Okay? Is alcohol toxic? Well, it can be. It is not in very small quantities. But if you were to take a large amount of alcohol, especially depending on what kind of alcohol it is, because alcohol is a wide range of things, ladies and gentlemen. From things like rum and vodka to things like rubbing alcohol and ethanol and methanol and things like that. Those things are alcohols that are burning, that are fuels. Don't drink those. Okay? So if you looked up alcohol and found out if it was toxic, you might have found that it could be or it couldn't be depending on how much you drink. Is vinegar toxic? No. Vinegar is something we put in coleslaw. Vinegar is something we put in barbecue sauces. Vinegar is something we put in a lot of the foods we make. Just about anything that you pickle is going to have vinegar in it. So it is not toxic. Sodium hydroxide. Sodium hydroxide can be a very strong base. It can be corrosive. It can eat away at your skin. And it can be toxic to you in high enough amounts. So that is what you probably should have had for there. Okay? Now what we did is we ran tests. Again, hopefully you went about this and said, okay, this one smells like alcohol. This one smells like vinegar. I'm going to identify them. But what was another way, if you couldn't tell which one was alcohol and which one was vinegar, what was another way you could tell them apart? According to our tests here. What does alcohol do that vinegar does not? Thank you. So maybe you could detect an odor out of two of them, but you weren't sure which one was vinegar and which one was alcohol. Well, now we have a second test. If we put a match near alcohol, it will burn. You saw that happen yesterday. Boom. Now we know which one is alcohol. The one that had an odor but didn't burn, boom. Now we know that it is vinegar. So we were able to distinguish these two things. Okay? Now, water and sodium hydroxide had no odor to them. Couldn't tell by smelling them. So what test separated water from sodium hydroxide? How'd you identify one? The sodium hydroxide reacted with this phenolphthalein and it turned purple. So again, you had two jars and you were like, all right, which one is water, which one is sodium hydroxide? Well, the one that turned purple, that was sodium hydroxide. All right, who could tell me what A was? Solomon, what did you think A was? Yep. Get it good?
Sodium hydroxide.
So you said A was sodium hydroxide. Anybody disagree? A. A was sodium hydroxide. It was the one that turned purple. Very good. Very good. It turned purple. Now, here's what happens sometimes in a lab. People test A, it turns purple, and they don't bother to test the others because it's not supposed to react, right? It is always still a good idea to test the others just to make sure that something isn't going wrong. Maybe there was something on the plate that was reacting. Maybe there was something that, it's always a good idea to test the others, even if you found the one that you think it is. Okay? So what was B? Damien, what did you say B was? B. What? You think it was vinegar? Good, because that's what it was. B was vinegar. And I can give you two reasons why. It had an odor, but it was not flammable. So, because it didn't burn, but it had an odor, that would make it vinegar, ladies and gentlemen. You're already seeing C here. C was water. What tests proved that it was water? One, it had no odor. Two, it didn't react with anything. It wasn't flammable. It didn't react with phenolphthalein, nothing. So the fact that it didn't do anything helped tell us that it was water. The fact that this one did something helped tell us that it was sodium hydroxide. Okay? And then finally, ladies and gentlemen, D had to be the alcohol. Why did it have to be the alcohol? Because one, it had an odor, and two, it was the one that caught fire. It was the one that was flammable. Okay? So, that is what you should have had. That is what hopefully you got. Questions? Okay. trying to tell you, what we were trying to show you in this activity, and I'm not collecting this, ladies and gentlemen, okay? You don't have to turn it in, okay? But what we were trying to show you is that you can identify things based on their properties or their changes. So the property of being flammable, well, if you set something on fire and it is burning, that means that it is changing, but that also means that that property is true. When that one liquid turned purple, that told us that it had reacted or changed with the phenolphthalein, and that tells us what it is. Some properties can help you, some don't. The color doesn't help us here. Toxicity doesn't help us because we're not going to drink something and find out if we die. Right? So some properties can be useful, some cannot. If not all of them were the same color, okay, find out which one is the color that you're seeing. Which one of them is supposed to be a blue color? Which one of them is supposed to be a yellow color? Which one of them is supposed to be a green color? Properties can help you identify things, ladies and gentlemen. And that is one of the most important things in science is when we come across something and we're not sure what it is, we have to start testing it, trying to figure out what it is. And the nice part is these properties, the ones that we talked about up here in the table, these don't change. If something reacts with phenolphthalein, it's going to react with phenolphthalein every time. If something is flammable, it's going to burn every time. If something has an odor, it's not going to suddenly be like, nope, today I don't want to have an odor. So these properties allow us to use them to help identify things. Questions? All right. We've got one slide to get through in our notes today, ladies and gentlemen. And that is this one, slide number 32. I'm going to double check and make sure it's 32 in yours. And it is. So please go to slide 32 in your EISN. Take and open that up real quick, please, ladies and gentlemen. I'll give you just a moment to do that. All right. So please remember, a chemical change is a change that yields a new substance. It is a change that creates something new, ladies and gentlemen. And there are some signs of it. Let's hope this works, ladies and gentlemen. Yay, this is the first time my hovercam has worked for a while. Okay, so I'm going to use this so you can see what goes on. I'm going to show you some reactions, and we are going to look at them, and we're going to say, okay, this is how we know that this is a chemical reaction. Okay? All right. Now, in here, ladies and gentlemen, there are 4 signs of a chemical change. 4 of them. Okay? Now, when a chemical change happens, not every one of these things will happen. But at least one of them will, and more than likely there will be 2 to 3 of them that actually occur. So just so you know, these things normally don't happen one at a time. 2 or 3 of them happen at a time. Okay? So the first sign of a chemical change, ladies and gentlemen, the first thing that will tell you a change is chemical. And by the way, if the change isn't chemical, what kind of change must it be? Physical. So while these things will tell you, hey, this was a chemical change, a change where these things do not occur means it's a physical change. Okay? Means it's a physical change. First sign of a chemical change, an unexpected color change. Now the key word here is unexpected. Please copy that down. An unexpected color change. Okay, if you take yellow water and blue water and mix them together, what do you get? You get green. That is just a matter of colors, right? If you take something that is yellow and something that is blue and put it together, it's going to make green. That is not an unexpected color change. That is what should happen when you put those two things together. If you take clear water and put green food coloring into it, it's going to turn green. That is not a sign of a chemical change. Okay? That is not a sign of a chemical change. We are expecting that to happen. So what do you see about these two liquids? What do you see about them? What color are they?
White and blue.
No, the liquids. Not the containers, the liquids inside. They're clear. They're colorless. There's no color to them whatsoever, correct? No odor. They look almost identical. They could be the same liquid. We don't know, right? But we're going to take and we're going to mix them together, ladies and gentlemen. Okay? We're going to mix them together. And let's watch what happens. Are you ready?
Is it going to be an explosion?
That's why I'm doing it right in front of my face. Yes, sir. Yes. They're going to explode right in front of me.
That's going to be very exciting.
Yeah, it's going to be very exciting. You ready? Here we go. Ready? 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 Now, it did not explode. But would you consider this an unexpected color change? Absolutely. Two clear solutions make something that is bright yellow. We were not expecting that, right? At least I hope we weren't. That is what we mean by an unexpected color change. Now, I'll bring this around, and you can look a little bit more closely at that. What? Looked orange? Okay, that's fine. But if you look in there, and you look closely, it's not like the water actually turned yellow. There are little yellow pieces kind of floating around in there. Okay? And what it has done is it has made the water look yellow. But the water didn't actually turn yellow. What turned yellow is this yellow substance that is inside there that is kind of sticking to the top edge. Okay? We'll get into what that is in a little while. But, okay, I mixed those two together. Do you think I got a chemical change? Yeah, because we got an unexpected color change. We got a color that we were not expecting at all. Good sign of a chemical change. Okay? Number 2, ladies and gentlemen. A gas is released. So if you mix things together and a gas gets released, that is a pretty good sign of a chemical change. Was a gas released here? How do you know? How would you know if a gas was released, ladies and gentlemen?
We didn't see it.
How would you see a gas?
How you normally see it?
I mean, I feel like you would smell it.
Okay, number 1, you definitely. A lot of gases you will smell. Not everyone, but many gases you will smell. And there are days where people walk into my room and they're going, oh, what did you do in here earlier? It stinks in here. Yeah, we did a lab where we made some gases. Okay, gases smell. What would you have seen in here if a gas had been released? You might have seen smoke or vapor coming off the top. Absolutely. Not every gas is colorless, too. Maybe you'll see the colored gas come off. But what else would you have seen in here as well? You would have seen air bubbles. Thank you very much. You would have seen bubbles that started out, that came up through this, that went off into the air. So again, we could see a gas. We can smell a gas. We can sometimes see the bubbles from a gas. Okay? You might even hear a gas. You might hear fizzing and popping and things like that, right? All signs that a gas was released. Now, was a gas released here? No. Doesn't mean that this wasn't a chemical change. Just means that there wasn't a gas release. Okay? Just means that there wasn't a gas release. Go ahead, sir.
Or maybe there wasn't enough gas release.
Well, that is true too. Maybe there was a very small amount, but I will tell you, normally with these signs of a chemical change, you will see them very clearly and very easily. You will normally see them very clearly, very easily.
What was in there? Water?
What was in there was a chemical called lead nitrate and sodium iodide. And when you put the two together, they make this yellow solid that is called lead iodide. Okay? That is the yellow solid that is in there. You see how this is getting a little bit clearer at the top, a little bit lighter, and down at the bottom there's a little bit more stuff? We'll talk about that in just a second with one of our other signs. Okay? So let's take a look at a gas being released. So in here, ladies and gentlemen, in my dish here, I have a piece of magnesium metal. Okay? This is magnesium metal. It is a silvery metal. It's in a strip here, and I have it sitting just in here. I am going to take and I'm going to add to that a little bit of acid. Okay? So we're going to put a little bit of acid in there, ladies and gentlemen. Watch and see what happens. Is a chemical reaction happening? How do you know? Okay, looks like it's boiling. Well, that is the what? What? Why? Okay, think of our signs. Is there an unexpected color change? I don't see any color change either.
Keep it the lighter.
Sure. Okay, which is what? A gas. Okay? What do you see in the water? If it ever tunes in. What did you tell me just a minute ago was a sign of a gas being released? What? No, bubbles. We got bubbles coming off of there. If you listen carefully, you can hear it reacting. You can hear those bubbles coming off of there. So that is a sign of a chemical change, that gas being released. There you go. There are those bubbles. We may not see the gas above it, but we see the bubbles. We hear it. That's a sign that this is a chemical change. A gas is being released. Now, the other thing that I could tell you that you're having a hard time seeing from where you are is the piece of magnesium is getting smaller and smaller. And eventually it will go away completely because it is reacting with the acid and changing into something new. Okay? No, well, it may appear to because some of it goes off into the bubbles and things, but you really don't notice it. But you will notice that the magnesium strip will be gone. Be totally gone. All right. So going back to our list. A third thing is a change in energy. Now, energy can only change in two ways, ladies and gentlemen. It can either be given off or it could go into a reaction. Okay? It can either be given off or it could go into a reaction. If energy is given off from a reaction, how does it feel? Hot. If you've ever gone outside in winter, maybe if you're going outside like to a Packer game or going ice skating or something like that, or ice fishing or whatever, maybe you take with you hot hands. Hot hands are those little packets that when you open them up and squeeze them, they give off heat so that your hands feel warmer. Some people put them in their boots if they're going out in the woods for a long time. Those are a chemical reaction where the change in energy allows them to get hotter. You feel the heat from that. But you could also have a reaction where instead of the energy being given off, it takes in energy. A good example of that is if you ever played sports and twisted an ankle or hurt your arm. The coach may go into the med kit and grab one of those plastic ice bags that doesn't have ice in it, but it's what is called a cool pack. And the coach would slam it and shake it up and then put it on your arm, and it would feel cold. Doing the exact opposite of what that hand warmer did. They put it on your elbow, they put it on your shoulder, they put it wherever you are hurting, they will put it there, and it will feel cold. And the reason it feels cold is because it's taking in energy. That is still a change in energy. Whether it goes out or whether it goes in, that is still a change in energy. And it doesn't even have to be heat. 4th of July, you see kids running around all over the place with glow sticks. They'll make glow sticks that look like glasses. They'll make glow sticks that they wave around in the air. Glow sticks are a chemical reaction where instead of giving off heat, they give off light. So the first thing you need to do to get a glow stick working is what?
You gotta shoot it, or
You got to bend it and then shake it up. Do you know why?
you get the energy, or mix the chemicals.
Inside the glow stick, there are two liquids. But one of them is inside another smaller container. So until you are ready for the glow stick to start glowing, it is separated from the other liquid. When you bend it, it breaks that tube inside. And now the two liquids mix, which is why you shake it up, it starts to give off light. That's a change in energy. Okay?
So
That's a
how
change.
come glow stick don't work all the time?
Well, glow sticks don't work. What? Run that by me one more time.
So you know, like you do it, and by the end of the hour, like the glow stick runs out of.
Well, any chemical reaction stops when you run out of the chemicals, when they've already completely mixed. My magnesium is not bubbling anymore.
That's because it's ain't no more.
That's because it's gone. Glow stick does the same thing. Once all the chemicals are used up in the reaction, it stops glowing.
I got a question. Is it bad to eat the glow stick?
What?
Is it bad to eat the thing that's inside of it?
Yes!
Damn. I think I tried it once.
I tasted it before.
Yeah.
That's scary.
Tastes like
Heavenly.
it.
When we were younger, we used to put the
I just
sticks in
bought
the
mine.
freezer and they would last longer.
Yes, because, very good. One of the things that controls how fast some reactions happen is temperature. So you're right. If you would take the glow stick and put it in the freezer, it would glow for a longer time. You could take it out and then it would start glowing again. Now, eventually, it's going to run out. It's going to stop glowing.
What about if you put it in the microwave?
It would speed up the reaction and it would glow for less time. So if cooling something down makes it go slower, heating it up makes it go faster.
Would it also
Don't
be
that stay in
brighter?
the microwave though?
Hold on. What?
Would it also be brighter if you heat it up?
It's not really going to be brighter. It may be a little bit, but not much. Not much. Don't heat it in the microwave to the point where you melt things.
Yeah, don't it keeps like the chemicals stay in the microwave so when you warm up your food?
No, because it's inside the glow stick. They're not going to get up. They're not going to get up. Okay? All right. So we got one last sign of a chemical change, ladies and gentlemen. And that is something called a precipitate forms. Okay? A precipitate forms. All right. I got one more reaction to show you here, and it's this one. Inside here is a piece of copper wire, ladies and gentlemen. Okay? Piece of copper wire. I'm going to put it into it some what is called silver nitrate. Okay? So I'm going to pour this in. Silver nitrate is clear. Silver nitrate is colorless. Silver nitrate is odorless. What happened? You tell me. Is anything happening?
It's rusty.
Anything happening? What do you think? Yes? No? Hard to tell? Maybe? Okay. Anything happening? There's some bubbles or something on the outside of the wire.
It's rusty.
Yeah, the wire does look like it's slowly changing color. Right?
That looks like some moss.
Something kind of building up on the outside of it. So would you say this is a chemical change or not?
Yeah, it's
Okay, I would say it's a chemical change. Okay? Now, physical changes come with chemical. Okay? But this is a chemical change. Here, now you can see that there's a little bit of stuff on the wire, right?
Oh yeah.
Okay. So we're going to let this sit here because unlike this reaction that happens, boom, almost instantaneously, that one's going to take a while. But here is the last one. A precipitate forms. Now, what is a precipitate? It is a solid that will settle out of solution. See all the yellow on the bottom here? That's the precipitate. This is getting clearer up on the top. Why? Because all the yellow, the solid, is now going and settling to the bottom of this container. That is what a precipitate is. It is a solid that will go and settle out of the solution. Okay? This is another sign of a chemical change. Okay? So this one, we had an unexpected color change in a precipitate form. All right? Good. Now, here's what I need you to do, ladies and gentlemen. I need you to go into the modules for the class, and let's see if I have it there for you. Hopefully I do. And go to the, am I in the right class? No. Hold on. Sorry. I know it's there. I don't know if you could see it. All right, you want to go to this aluminum and copper chloride lab, ladies and gentlemen. I need to edit it and set a due date on it. Let me do that real quick. All right, so open up this aluminum and copper chloride lab, please, in your modules. Here's what it looks like, ladies and gentlemen. Okay? So, in this lab, what you are going to do is you are going to determine if 3 steps where you will see changes, if they are chemical changes or physical changes. Now, again, we have just given you the signs that tell you if something is a chemical change. Here are the signs that tell you if this is a chemical change. So when you are doing this lab, if you see these things happen, that means that that step was a chemical change. If you do not see these things happen, it means it was a physical change. Very good. And that is how we are going to write this up in the end. This step was a chemical change because it got hot. A gas was released. There was an unexpected color change. Yes?
Is there also a mental change?
A what?
Mental?
No. Chemical or physical, that's all we will deal with here. Thank you. Okay? All right. So, back to the lab. You are going to take and you are going to begin by putting 25 to 30 milliliters of water in the beaker that is at your desk. There is one at each lab station. And the marks on this are good enough. 25 to 30, you can use the marks on the side here, are somewhere between the 20 and the 30 line on it. Okay? It doesn't have to be exact. 25 to 30 milliliters of water. Now you are going to take and make observations of that water. What you see, what you smell, what you feel will get you 3 observations, ladies and gentlemen. So tell me how the water feels, tell me how the water smells, tell me what color or what you see in the water. At your station, there is also a little dish like this. It is called a weighing boat. It is white, but it has a substance inside of it that is copper 2 chloride, that is the 2 to 3 grams already weighed out for you. So, when you look at it, ladies and gentlemen, there it is. You could see it, you could smell it, you could touch it, but when you are done touching it, please wash your hands. So that will be your 3 observations. What you see, what you feel, and what you smell. By the way, if there is no odor, putting down no odor is an observation. Okay? Next, you are going to slowly add this to the water. And you are going to swirl this around. This is the first time where we have made a change. This is the first time that we have made a change. The question is this change a physical change or a chemical change? Now you know what to look for a chemical change. Is it getting warm? Is it giving off a bunch of bubbles? Is there an unexpected color change? All of those things, ladies and gentlemen, are there to help you figure out if this is a chemical or a physical change. Now you will put these things down here. What you see happen when you added the water and the copper chloride. You need to fill in at least 3 of these boxes. 3 observations. Step number 4, obtain a small piece of aluminum foil and make observations. So there is a piece of aluminum foil at your desk that looks like this. Make observations of it. What you see, what you feel, what you smell, any observations, but you need to make 3 of them. And again, they go back up here. Should have all of this done now. Step number 5 says loosely roll the aluminum foil into a stirring stick. What I mean by that is you are going to take and you are going to roll it up so that it kind of looks like a straw. Okay? Kind of looks like a straw. Not real tightly done, just nice and loose like this. This is a spot of another change. When you rolled it up, write down what you saw for changes down here. You need to give me at least 3, otherwise you're not getting the point for it. And you also should ask yourself, all right, did it get hot? Was there an unexpected color change? Did a solid settle out of solution? Well, it couldn't. Was a gas released? Okay? Your last step is you are going to take and you are going to stir around this stuff with this off and on for about 5 minutes. And you are going to write down what you see happening, what you feel, what you hear, what you smell. So you're going to take this and you're going to stir this in here and mix it all around. Let it sit for a few minutes, mix it around some more. Let it sit, mix it around some more. And you are going to put your observations down here for what you see. Okay? That is what you have to get done. We will then talk about your conclusion after you are all done with that. Okay? But please remember, you are always looking for these signs of a chemical change. You are looking for unexpected color changes. You are looking for a gas to be released. You are looking for it to get hot or feel cold. You are looking for a precipitate to form. Okay? Questions? Now the last thing, ladies and gentlemen, when you are done with this white tray goes into the garbage. These wastes cannot go down the drain. So in the back of the room here, there is a container where I want you to put them on the center of the lab station here, this big jar. So what you'll do is you'll take your aluminum foil and you will throw it in there. You will take this, and it is very important that you do this. You will swirl this around, meaning move it around in a circle, and you will dump it really fast to get everything out of there. Now, I did not get everything out of there. You see all the stuff that's in here still? So then I take this bottle, and I hold it above it. I don't put it inside it. I hold it above it, and I get a little more water, and now I do that. I dump it again. A little more water, dump it until this is fairly clean. Take this to your sink, squirt a little soap in it, grab one of these brushes, clean it up. When you're done, just dry it. You can use either the cloth towel or the paper towels, I don't care. And put this back in the middle here for me. Right there. There'll be nothing left at your lab station and you will be done. That is what you need to get done before the end of the hour, ladies and gentlemen. Questions? Now, I have 5 stations set up over there. I have 5 stations set up over here. That is more than enough for all of us. I did not set one up at that side over there, Damien, where you guys normally work because there's no sink there for you. So I thought I would move it over here for you. Okay? There are only 12 of you here, so we probably will only use 6 of the stations. You don't need any more than that. Partner up, get to a station, let's go get this stuff. Strong smell.
Can you tell me what you see? Can you tell me what you feel? Can you tell me what you smell? You will get 3 observations. So, and you can make multiple observations of what you see.
you have questions, ladies and gentlemen, let me know. To the point where you're mixing this stuff. You haven't even put this stuff together yet. Come on. Great observation. What you see, what you feel, what you smell. That is not typical. No longer. Good. Move on. Mix these stuff together. Roll up your paper or your aluminum foil. Tell me what kind of change that is. Yeah, definitely. Definitely. Okay. You can actually dry your finger and put it in the middle over your white stripe. Your partner's gonna finish on his own without you. Is he okay with it? You can be done in 5 minutes. Hey, so right? Hey, go. By the way, come up, take a look at our two experiments and see how different they are now than they were earlier, ladies and gentlemen. Especially the one over there. Yep. Clean up your stuff, head back to your seats, and we'll talk about that.
Throw it around and dump it quick. Dump it quick, dump it quick. There you go. Now you throw it out. Perfect. Perfect. You realize it.
All right. All right. Let's talk about your conclusion. You can get that written. You can finish that up. You can turn this in before you leave. You'll have nothing to worry about for the rest of the day, ladies and gentlemen. All right. So, let me kill the music. Okay. So, the last thing that you need to do for the lab is write a conclusion. Now, of the 3 steps you did, step 3, step 5, and step 6, you need to determine if each of those steps was a chemical or a physical change. Once you have determined if you think that the step was a chemical or a physical change, the conclusion that you are going to write, you will begin by saying, in this lab, step this, and this were all this kind of change. Or step this and this were a physical change because there was no energy released, no gas formed, there wasn't an unexpected color change. You have to give me those reasons as to why it was a physical change, what things did not happen. Then, step this was a chemical change. And which of those signs of a chemical change did you see happen that told you this step was a chemical change? So for the physical change steps, you tell me what did not happen. For the chemical change steps, you tell me which of the 4 signs did happen. And that is the conclusion that you will write. You need to make sure you include all 3 steps. If 2 of them were one kind and 1 was another, you could tell me these 2 were this kind of change. And then why? What did or didn't you see that tells you they were a physical or a chemical change? Please remember, if you are going to tell me they were a physical change, you should tell me that you did not see these things happen. If you are going to tell me that it is a chemical change, you should tell me which of these you did see happen. That is the justifying your reasoning. Okay? You have 6 minutes left to the hour, ladies and gentlemen. Please get your conclusion done and please turn this in before you leave. Questions? Excellent, ladies and gentlemen. Go to work, get it done. If you have questions, call me over. I will be happy to come over and assist you.